You've seen this before, a spiral unfolding before your eyes. From the shell of a snail to the swirl of a galaxy, the symmetry of nature appears everywhere, revealing an underlying order. The hexagonal precision of honeycombs, the branching of trees, and the spirals of storms all follow a hidden logic. But why? Look closely, and you'll notice these patterns are repeating themselves at different scales. From the delicate veins of a leaf to Earth's vast weather systems, nature seems to operate from a common blueprint. This is not mere coincidence. These patterns are the fundamental expressions of the forces shaping the universe, governing physics, biology, and even art. More than aesthetic, they serve as survival mechanisms, structural necessities, and echoes of universal laws. The prevalence of these patterns stems from physics and mathematics. Consider the Fibonacci sequence, a series of numbers that manifest throughout nature. This sequence dictates the spiral growth of shells, sunflower seeds, and pine cones, optimizing space and resources. For plants, this arrangement ensures that each new leaf or petal is positioned to capture maximum sunlight. This phenomenon, known as phyllotaxis, follows a predictable mathematical pattern, one that maximizes space and light exposure. If leaves grew in a simple stacked formation, the upper leaves would cast too much shade on the lower ones, reducing their ability to absorb sunlight. Instead, plants use an angle close to 137.5 degrees, known as the golden angle, to ensure that each new leaf is offset in a way that minimizes shadowing and maximizes exposure to essential resources. To understand nature's preference for specific patterns, we have to look at efficiency. The hexagonal structure of honeycombs, for instance, isn't a result of bees consciously measuring angles or performing mathematical equations. Instead, the cells start off as circles, molded by the bodies of bees as they build their wax structures. As the wax is heated and softened, surface tension and natural forces cause the cells to settle in a hexagonal pattern. In the same vein, the spiral of shells maximizes volume while using minimal resources. Interestingly, humans have long recognized and replicated these patterns. The Fibonacci spiral appears in architecture, from the Parthenon to modern design, embodying harmony and balance. One of the most famous examples of the spiral in art is The Birth of Venus by Botticelli. If you overlay the Fibonacci spiral onto the painting, you'll find that the curve naturally aligns with the movement of Venus's body and the flow of the surrounding figures. This intentional use of the spiral creates a sense of harmony, guiding the viewer's eye in a smooth, natural progression. Painters, sculptors, and graphic designers incorporate these forms intuitively, as they resonate with our innate sense of beauty. Beyond Earth, these patterns extend to planetary phenomena. The swirling currents of oceans, the branching of river systems, and the formation of storms mirror the structure of galaxies. Satellite imagery confirms the fractal-like consistency of natural designs, reinforcing the idea that these patterns emerge from fundamental laws governing both the microscopic and the cosmic. Fractals, another common pattern, are self-replicating shapes visible at every scale. The branching of trees, the veins in leaves, and the flow of rivers all exhibit fractal geometry. These structures provide stability, guide growth, and optimize resource distribution. Fractals extend beyond the organic realm. Mountain ranges, lightning bolts, and even the large-scale structure of the universe exhibit similar formations. From a satellite's view of Earth's terrain to microscopic cell structures, fractals highlight the universal principles of nature. At the heart of these recurring patterns lies evolution. Over millennia, natural selection has refined life forms for efficiency. The geometric and mathematical structures in nature are not random. They represent optimal solutions for survival. The human circulatory system follows a fractal-like structure, with larger arteries branching into smaller arterioles and finally into capillaries. This hierarchical design ensures that oxygen and nutrients efficiently reach every cell in the body while minimizing the energy required to pump blood. Similar branching structures can be seen in the respiratory system, where the bronchial tree optimizes airflow to the lungs. These patterns illustrate how evolution consistently favors structures that maximize function while conserving energy. The patterns we see in nature aren't just visually pleasing, but fundamental to the universe's operation. They provide efficiency, stability, and function, reflecting nature's ability to solve complex problems through simple, repeated structures. The deeper we look, the more we realize these patterns aren't just aesthetic, they're essential. Embedded in the smallest life forms and extending to the vastest galaxies, they reveal the interconnected nature of existence. In the flow of rivers, the arrangement of petals, and the dance of the stars, we witness not just beauty, but survival itself.